Hello there, it's Luke, and in this tutorial we're going to introduce you to the concept of polarity and explain some terms to do with polarity, depolarisation, repolarisation, action potential and threshold potential. And these concepts are really important for understanding the action of cardiac myocytes, so the heart muscle cells, but also how nerves transmit impulses, so they transmit information within the nervous system. So polarity is the term used to describe how far from a neutral balance a cell is relative to the surrounding cells and fluid. And here's a cell, okay, and you can see that within that cell there are some positively charged ions, some cations, but surrounding the cell there are many more. There's a far greater concentration of cations, and so we might say that that cell is polarized. It's negatively charged compared to the surrounding environment. So here we are. We're just a diagram explaining that. So again, you can see there are fewer cations within the cell, so it is negatively charged compared to its surroundings, and we would say that that cell is polarized. If the same cell becomes more positively charged due to an influx of cations, it is said to be depolarized. This is because the cell's negative polarity has moved towards a neutral or even balance by the influx of cations. If cations leave the cell, then it becomes repolarized, as it becomes more negatively charged relative to the nearby fluid or cells. At rest, cardiac myocytes and neurons are polarized with a negative charge relative to the surrounding tissues and cells and fluid. Cardiac myocytes are stimulated to contract by action potentials. An action potential is the spread of positive charge from one cell to another, a chain reaction of depolarization. A cell does not have to become positively charged or even have a neutral balance of ions to spread an action potential. For the action potential to spread through that cell, it is only required to be less polarized. The point at which the cell is sufficiently depolarized is called the threshold potential. So there we go. So if you're above that threshold potential, you would have an action potential which might result in muscular contraction or the spread of sort of positive ions from one cell to another. And if you're below that threshold, there's no action potential, and so nothing happens. Now, if we go back to our diagram of the cell, you can see that we've had an influx, so a lot of positive cations have entered the cell, and the cell has become depolarized. It's moved above the threshold, and we can see that an action potential would occur. And if that was a cardiac myocyte, that might mean that the cell contracted, or the action potential or impulse spread throughout the sort of conducting system cells of the heart. However, in this diagram, fewer cations have moved inside the cell, and so it's not changed its charge sufficiently. It's not become sufficiently depolarized to meet threshold, and so no action potential occurs. So in summary, we've introduced the concept of polarity. We've said that depolarization occurs when positively charged particles or cations enter a cell, and action potentials occur when a cell is depolarized above the threshold potential. Thank you very much for listening.